This question tells us that the normal to this curve at this point, 2, 1, cuts the curve at a second point, Q, here. And we're asked to find the coordinates of Q. So first thing we need to know is find out what the equation of this normal is. So to find the equation of the normal, we need two things. First, we need to know the gradient of the normal. And secondly, we need to know a point on the normal. Well, the second one we've got already actually. Why? Because we know it's the normal at this point here. So we know 2, 1 lies on this normal. Now all we need to do is find the gradient of the normal. Well, we know the gradient of the normal is equal to -1 over the gradient of the tangent line. So if we can find the gradient of the tangent, we can find the gradient of the normal without any problems. And we know how to find this value, the gradient of the tangent. That's just the gradient of the curve at the point 2, 1. So, what do? We differentiate. So if you differentiate x take 1 squared, well, dy dx, the 2 comes down, you get x take 1 to the power of 1, and then you differentiate the inside, which is 1, so you're left with just this. So the value of this at 2, 1, what do? We substitute 2 in here. So we get, this is equal to 2 minus 1, which is actually just equal to 2. So this is the gradient of the curve. Therefore, the gradient of the normal is going to be -1 over 2. So now we've got a point and we've got the gradient. So we're good to go. So we know, we have the equation y minus y1 equals to mx minus x1 to find a curve given the gradient in 2 points, the straight line, sorry. So y minus 1 is equal to -1/2 x minus 2. So if you simplify that, what do you get? If you simplify it, you get y equals to -1/2 x plus 2. Plus 1 from -1/2 times -2, and plus 1 from this one coming over. So now, when does the normal cut the curve again? Well, we know what we have to do then is solve the simultaneous equation, where this is our first equation and this is our second equation. So we can sub 1 into 2, and what do we get? We get 1/2 x plus 2 is equal to x take 1 squared. So 1/2 x plus 2 is equal to x squared take 2x plus 1. So x squared minus sorry, this should be -1/2 minus 3 over 2x plus 1 plus 2, so this will be -1, is equal to 0. If you factorize this or use your GC, you find this is x take 2 x plus 1/2 equals to 0. So x equals to 2 or x equals to -1/2. So we already know what the coordinate is. This one here, x take 2, this is our coordinate, x coordinate for the point P. So that means this one must be the x coordinate for the point Q. So what are we going to do? Well, we need to find the x-coordinate of the point Q is x equals to -1 over 2. So what is the coordinate? Therefore, the y-coordinate is, we just substitute it in to this equation, the equation of the curve. So we get -1/2 minus 1 squared, which is equal to 9 over 4. So we can say, therefore, the point Q has coordinates -1/2, 9 over 4.